So the last time I did this, there was no sound. This time there is sound. There should be. If I have to take a break during this video, I might have to take my dog outside. I do not know. He may or may not need my assistance. Sorry about that. I will do not disturb. Okay, so for our first thing that we're doing, we're making a log standard curve with our ladder, which is right here. This is the blown up version of this right here. So if we look at that very top one, we know that that is 10,000 or 10 kilobases, 8 kilobases, 6, 5, 4, 3, 2, 1.5, 1, and 500. We know that because the company will not fail us. The shareholders, the big science has told us that this is it, and this is the blown up version. This is the scale that they gave us, and here's our ruler over here. So when we look at our ladder, I measured the distance. So I got a little sticky note, went all the way across, and I said that was approximately 3 centimeters. So I went over here to the left, marked 3 centimeters, and converted it to the distance in millimeters, which is 30, and I did that for all of these little bars right here, all the way down to the last one. And here are the values I got in centimeters over here, and then I converted them to millimeters, which is where we will be doing our which is what we'll be using in our calculations. So for this case, and we know that each of them is this size in base pairs, thanks to the company, to Big Science. And so the first thing that we do is log 10 of 10,000, and that gives us 4. And the next thing that we're able to do is, because of Excel, big Excel, we can drag down here, and it calculates all of the other values. Did log 10 of 8,000, 6,000, 5,000, so on. So here's all of our values, and our distance migrated, and our log. So what we want to do, the most important things we need, I'll put this in orange. So the log, or the log standard curve that we'll be making, we can highlight these two. Insert, we want a chart, a scatter with only markers, and boom, there is our here's our curve. Well, not yet. We have some other stuff we got to do to it. We need to name it. We need to add a little trend line. Go here, added a trend line, and we want it to be logarithmic. And I want it, you guys don't have to do this, but I want it to be a solid line. We want equations and values. Just gave us that right there. We also want the r squared value. I'm gonna move that up here so it's a little bit easier to read. That equation will be highly, highly important. As you can see here, the r squared value is super high, almost 1, which is perfect, indicating a almost perfect correlation. I'll try and drag. Never mind. Okay, that's all we need for that. Got our trend line down, but we also need to label the axes. So we want for our vertical axis, we want to have a title, and the title will be size in kilobases, fragment size in kilobases, log. There we go. Should appear right there. Perfect. Beautiful. Now we no longer want. Now we want. Okay, I think my dog wants me to go outside. Well, I will not be going outside with him. I'm just going to let him out real quick. And down here on the bottom, we want this to be distance migrated in millimeters. There you go. All right. we have officially labeled that, and what do we want our chart to be called? What would we want this chart title to be called? Log standard curve. Done. Beautiful log standard curve right there. And it gives us this gorgeous equation that will be highly important for this next part to calculate the true value of our R1, R, M1, M2, M3. And so what I did here was I did some more measurements across, went over here, and this is our R lat, this is our R lane. As you can see, this is the first lane, the second lane, R is in the third lane. And we can see 1, 2, 3, 4, 5, 6 lanes in this gel. So we're going to go over here to, I set this up, our R. I measured out the distances. I estimated, using our trusty ladder over here, knowing that this is 10,000, I said, that one's a little bit higher than that, about 12,000, and so on. Then this next one, I said, that's roughly 8. That's, roughly, those are about the same thing. That 8 up here, it's roughly 8,000 kilobases. And then I went over here for each of them, marked the distance in millimeters. So the first one was roughly 28. Marked them for that one. If we look at the second lane for M1, I marked the distances here, also estimated. M2, M3. So for R, start with the first part. Because we have our trusty equation, and I need 1.331 times the natural log. Why is it being weird? The natural log of the distance traveled in millimeters plus 8.5322. Gives us our first value. Oh yeah. Gives us all of those values. However, we need to remember that this value is in kilobases. So we need to get it back to, not kilobases, but we know that this value there has been a log applied to this value up here. And to reverse the log, what we would do is equals 10 to the value there, and it gives us our calculated true value. We can drag that down, and it gives us all of our other values. Time for a big repeat for the rest of them. So go down here, equals negative 1.331 plus natural log of the distance traveled plus 8.5322. There we go. Drag that down. And then 10 to the equals 10 to the right there. Let's redo that really quick. Equals negative 1.331 times natural log distance traveled plus 8.522. There we go, that's better. Drag that down, equals 10 to the value right there. Estimated size, drag that down. Perfect. I'm gonna check on my dog real quick, please be patient. Oh, lovely. He is just sitting in the grass, soaking up the sun, which I will be joining him shortly. Okay, for the next one, equals negative 1.331 times ln of the distance traveled in millimeters plus 8.5322. And remember, we're getting this equation from our log standard curve. Bam. Another value, drag that down, equals 10 to the value right there. Perfect. Last one, 1.331 times the log of the distance traveled in millimeters plus 8.5322. There's our value down there, equals 10 to the value. There we go. And so what you need to turn in is, on a Word document or whatever is easiest, I want you to turn in this graph right here, these values right here. And you can take screenshots of this stuff and post it. And I want a table like this for each of these. You can make tables in Word. You can make them in Google Sheets or whatever you choose to do this with. I'm doing all of this in Excel. But what I want you to turn in, I need to see this. I need to see the equation. I need to see a table like this. I need to see a table like this for R1, M1, M2, and M3. And I need to see this up here. I need to see that you did the work. All right. This is, yeah, that's everything. If there's anything else, email me. I hope this one helped. I hope that, I'm sorry about the first one not having sound. It should have, and I apologize for that.